Good day, sir. For this video, I will be discussing my CO1 assessment. So, for task 1, we need to discuss our drawing, which is block diagram showing marine radar key component and its function. For our marine radar component and radar block diagram, so this is my answer, sir. We have marine radar component, we have antenna, transceiver, power transformer, display. And for our receiver, we have mixer, first amplifier, equalizer, video amplifier. For our transmitter to transceiver, we have magnetron, modulator, and also trigger. For our radar antenna, transmit and receive in a concentrated beam, and a motor turns the antenna. The signal which are amplified and becomes visible to the operator in the form of a picture in a radar screen. For our transceiver unit, we have generate wave and process the signal. To receiver, the incoming signal in read to a series of amplifier and Fortner to detector or demulator for which smoothes the signal. For our transmitter, it triggers pulses to the modulator and convert the input into high frequency transmitter receiver switch. For our display unit, we have display or radar screen and connected sensor data. Processing unit, we have to process signal from radar component and external devices. So for our task 2, we need to discuss our drawing, the basic principle in which radar determine the bearing and range of reflecting object. So this is our answer. So in our task 2, this is our answer. So the basic principle of radar determine of range of an object and target by measuring the time required by extremely short pulse of very high radio frequency transmitted as a radio wave to travel from a different source to a target and return to a reflected echo. Bearing to a target is determined by a direction from which a reflected echo return. A marine radar scanner takes 360 above vertical axis using gear. So for our task 3, we need to discuss at least 3 radar and ARPA errors and at least 3 radar or ARPA limitation. So this is my answer. For our task 3, we have our radar ARP or ARPA errors. We have bearing errors, range errors, target loss. The target data may be transferred to a transient echo, which then disappear. We have random tracks errors. These are caused by input errors from radar, which causes unstable computation of erratic target behavior and speed errors. For our radar or ARPA limitation, we have it cannot distinguish and resolve multiple targets which are very close. It cannot recognize color of the target. It cannot see target which are in the water and too deep. It cannot see target which are placed behind some conducting, and also it is also difficult to recognize short-range target types. So for our task 4, we need to analyze below the radar vector plotting with what situation as per international regulation for preventing collision at the sea 1972 as amended, and we need to explain and answer. So based on this situation, the target vessel did not alter course in the base on the situation of regulation 19 of Colgrass. A collision exists other early as possible to starboard side to avoid collision. So for our task, we have this for our answer. So for our diagram, this is our diagram number 1. For our diagram number 1, Colreg 13 overtaking. This diagram shows that it is an overtaking situation because the target vessel is going also at the same direction. For our diagram number 2, we have this. For diagram number 2, we have Colreg 14 head-on situation. The vector plotting shows a head-on situation. Each vessel should alter her course to starboard so that each shall pass on the port side. For our diagram number 3, for our diagram number 3, we have Colreg 6 safe speed. This vessel or diagram show that every vessel shall at all times proceed at the safe and speed so that she can take proper and effective action to avoid collision. That's all, sir.